Friends, this is called the Coulombs law. The Coulomb was the one he found that how to find the magnitude of the charges or the magnitude of the forces acting between the charged bodies. That is obviously. So now he found that if two charged bodies, suppose Q1 and Q2, are kept like this, separated by a distance r. Suppose I take this is a tiny body which has a charge Q1 and this is another charged body which has a charge Q2 on them. Then the Coulomb found that there is a force acting between them, and that force is directly proportional to product of charges and inversely proportional to square of the distance between them. So if you combine this, the greater is the charge of them, the stronger is the force, and when the charges are very close to one another, then this force is also stronger. I mean, this force follows the inverse square law, and if you plot the force with the radius, then you will have something like this. This is force and this is radius. So relations between them will be something of this kind. When the radius is decreasing, the force will be increasing. When the radius is increasing, the force will be decreasing. Now here, when he combined these two, then he found one single law, that is F equal K. This is constant of proportionality, Q1 Q2 over R square. Later experimentally it was found that the value of K is 1 upon 4 pi epsilon naught Q1 Q2 over R square, and this epsilon naught is a quantity and its value is epsilon naught is 8.854 into 10 to the power minus 12. And this one, what will be the unit of this epsilon, and how we find the unit of this epsilon? Unit of this epsilon is just like, suppose if I say that this becomes FR square upon Q1 Q2 is 1 by 4 pi epsilon naught. So now we just reciprocal it, then we find that the 4 pi epsilon naught is Q1 Q2 over FR square. Since the 4 pi doesn't contribute anything in the dimensions, so I simply ignore it, and then I find that the unit of Coulomb into Coulomb, this is Coulomb square over Newton meter square. So this is how you can find the dimensional quantity, and the value of this 1 by 4 pi epsilon naught altogether is 9 into 10 to the power 9. So you can say that your force F is 9 into 10 to the power 9 Q1 Q2 over R square. Now just assume that if these two charges Q1 and Q2 both are of the magnitude 1 coulomb only, so Q1 is equal to Q2 and that is 1 coulomb, and the distance of separation between them is R is 1 meter, then you find that F becomes just 9 into 10 to the power 9 Newton. Means you can say that when two charged bodies, both having the charges 1 coulomb each, and they are separated by a distance of 1 meter, they will repel or attract depending on the nature of their charges by a force that will be equal to magnitude 9 into 10 to the power 9 Newton. This is the idea of this force. Now just let me clear the screen and then I'll discuss about the vector, because force is a vector quantity and you need to know the magnitude as well as its direction. That is very important and the pivotal part. Okay, so now to understand the vector form, I have to draw a grid system, and this is my position O, this is x-axis and this is y-axis. Suppose I have one charge here at point A and its position vector with respect to A is R1. So this is R1. So OA bar OA bar is R1. And now I have another point B, and there I have position vector is R2 bar. So you get OB bar is R2. Now the arrow should be like this because this is a vector quantity. Now I have to find the AB, so I'll connect this AB. Then I find that this is my AB. So I have a charge here Q1 and another charge here Q2. So now you see that if I try to find out the triangle law, so suppose I go from here to here. So the triangle law says that R1 plus AB bar is equal to OB bar, that is R2. So AB bar will be R2 minus R1. Now AB bar is R2 minus R1, and what does it mean? That this is AB bar is R2 minus R1, means it is from 1 to 2, from 1 to 2, and that we write as R21. So R21 is R2 minus R1, and its significance is from 1 to 2, means from this to this. So what is R2? 1 is R2 minus R1, and the sense of direction is from 1 to 2, means from A to B. It's just like 1 to 2, so it goes like this, and that is represented as R21. So if I go like, suppose if I change the direction, then R12 will become R1 minus R2, and the change of direction will, what is sense of direction, from 2 to 1. So 2 to 1 means here also, suppose because 1 is A, and here you can say from 1 to B, so this is, you can say AB, and then what is this? This is BA, because just opposite of that. This is the vector notation in terms of the direction. That's why you have to pay little attention over this. Now what we have to find? We have to find the force on this due to this, and that will be represented as force on 1 due to 2 is 1 over 4 pi epsilon naught Q1 Q2 upon, this is R12 square, and this is R1 unit cap. So R12 square means this is when you have the square of a vector quantity, this becomes directly a scalar quantity. For example, suppose if you do not understand the vector, then you can say, suppose if R bar is AI cap plus BJ cap, so R square is R bar dot R bar, and this will be nothing but A square plus B square. So this is just a pure scalar quantity. Now the what will be the direction is from 1 to 2. So R12 just like this here. But the interesting part is there, like if the charges are alike. So suppose if Q1 and Q2 are positive and Q1 and Q2 are negative. So in these cases we can say that if Q1 and Q2 both greater than 0, means Q1 is positive, Q2 is, because positive into positive can also be greater than 0, negative into negative will also be greater than 0, but the positive and the negative will be less than 0, and the negative and positive will be also less than 0. It means this is repulsion and this is attraction. So suppose now, for example, if I say that the Q1 is positive, so Q1 is positive, Q1 is positive and the Q2 is also positive, then the force on 1 due to this will be repulsive in nature. So this will experience one repulsive force, in this direction, and that direction will be from 2 to 1. That direction will be from 2 to 1, and from 2 to 1 is this one. This is from 2 to 1. So it means, now you see, the vector will become R12. This is R12. The force on 1 due to 2 is 1 by 4 pi epsilon naught Q1 Q2 upon R12 square, and in the direction 1 2. And what is 1 2? From 1 to, from 2 to 1. So from 2 to 1 means in this direction. This is 2 to 1, because this is position 2 and this is 1. So naturally it is just justifying whatever we have discussed. Now same way, suppose the force experienced by this charge due to this will be F21 is 1 over 4 pi epsilon naught. Magnitude will remain as it is, R21 square, but the direction will be R21 I cap. So this one is a unit vector, means its magnitude is just 1, but the sense of direction is from 1 to 2, means from 1 to 2. And this one you can also call it as BA, and this one is AB. It just depends on how you feel, because here you say R21 means from 1 to 2. So from 1 to 2, so it means this will also attract a force on this one in this direction. So the force on 1, again I am just giving a revision. Force on 1 due to 2 is F12 1 by 4 pi epsilon naught Q1 Q2 upon R12 square R12, and R12 means from 2 to 1, means in this direction, and that is B to A. That's why I have written BA bar. And the force on 2 due to 1, and always keep this in mind, we are discussing this set where the product of the charges is greater than 0. Now if the charges are not this one, like if they are different, then this R12 will only change. Like here in this case, R12 will become R21, and the R, so here again I write, in the case of these two I mark it as like the repulsion set of forces. These two are repelling each other, but what if they are attracting? Like suppose if Q1 is negative and Q2 is positive, so the force on Q1 due to Q2 will be that it will pull it towards it. So the direction will become from A to B, and from A to B is given as R21. So everything will remain same, but this 1 2 unit gap will become 2 1. So it will become something like this. F12 is 1 over 4 pi epsilon naught Q1 Q2 over R12 square, and this is R21 unit gap. Same thing here, and at the place of this 2 1 it will become 1 2. So this is all about the Coulombs law in the vector form. I hope that I have cleared my explanation and everyone might have understood it well. And in the next video we will learn about the Lami's theorem and how the Lami's theorem help you to find. Can we start in the next video or the same video?
Next video.
Okay, so in the next video. Thank you very much.